السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي، ومن منصة البث المباشر وزارة التربية والتعليم نرحب بكم جميعا مع تحيات فريق المنصة. طبعا احنا في السيشن الثالثة الخاصة بالريفيجن شابتر 1. شابتر 1 طبعا احنا اشتغلنا فيه 2 سيشنز، السيشنز الأولانية والثانية كنا بنتكلم على البارت الأولاني الخاص بتجميع اللوز، وبعد ما جمعناها بدأنا ناخد شوية بروبلمز ونحلنا عليها. طبعا نكمل شغلنا ان شاء الله. ديت اخر سيشن خاصه بشابتر 1. ان شاء الله اللقاء الجاي باذن الله هنشتغل بقى السيشن اللي جايه، هنشتغل فيها الجزء الخاص ب شابتر 2 وشابتر 3. هنا نتكلم عن الجزئيه الاولانيه. firstly ion concentrations used dissociation stoichemistry. We have K2SO4 when ionized in 2K plus 1 and SO4. We have many atoms here, but now we discuss the dissociation of ions. Now we have 2K positive and SO4, it is the polyatomic groups. SO4 is negative 2. This is a salt. When it dissolves in water, is dissociated into two types of ion. Now we have AlCl3. Now we have Al and Cl. Al, we have 1 mole of aluminum ions, Al plus 3, and we have 3 moles of chloride ions. Now, if the salts of 0.4 molar, then K positive equals 0.8 molar. Why? Because you multiply 2 times number of mole of the total compounds. Now we have the same in AlCl3. We have multiply 3 times the number of moles of AlCl3. We can to detect the number of moles of chloride ion in these salts. Now, number of molecules, when you divide it into number of 6.02 times 10 power 23. Now the results is number of ions. Number of ions. If you have number of moles, multiply of 6.02 times 10 power 23. It is Avogadro's number. I can to summarize by Na. This Na is expressed the Avogadro's number. Now the formula units you express, you must dissociate it into 2 types according to the salts, if you have, or the acid or base or anything. We have oxygen in these compounds. K2O contains 1.5 moles of ions. How? We have 1.5, we have 0.5 moles. 1 mole equal to 3 moles of iron. So 0.5 moles equal to 1.5 mole of ions. And 1.5 times Na, it is the number of ions. Na equal to 6.02 times 10 power 23. You must save this number is Avogadro's number. This is Avogadro's number. Now we can continue the revisions of this low gas stoichemistry used in this part 2. You explain some algebras. It combines balance coefficients with volume. If you want to detect the volume of any gas, you must multiply number of moles times 22.4. This is STB, not RTB. If you using RTB, you must multiply in 24, not 22.4. This is the difference between STB and RTB. Focus and condition. If I ask you the condition STB, now you use 22.4. Okay? Identify the limiting reactants where this 24 liters of hydrogen and 14.4 liters of oxygen at RTB reactors in this reaction. Now, In this reaction, you want to detect the limiting reactant. Okay. Now you must know the ratio between hydrogen and oxygen in this reaction. If you detect the ratio between them, you choose the least number of ratio. Now we have the ratio is 2 1 2 1, 2 hydrogen and 1 oxygen. If the number less than 2 or oxygen less than 2, now the ratio will detect the limiting reactants here. Now, according to the numbers you want to calculate it, now you have RTB, you must divide it 24 liters to 24 equal to 1 mole of hydrogen, 14 liters 0.4 divided to 24, this is equal to the number of moles of oxygen. Now we have hydrogen or oxygen or H2O or non-limiting reactants. Now the correct answer is what? This depends on the number of moles of reactant and the ratio between them. Now we have hydrogen equal to half moles. Now we have oxygen equal to 0.6 moles. This is the ratio, depends on the smallest number is 0.5 is what is hydrogen. Then so the A is limiting reactant because it consumes totally in this reaction. Consumes totally in the final reaction when you finish that. And 3FE when reacts with 4 H2O, it is Fe3O4 plus 4H2, 16.5, 16.8 grams for Fe and 10 grams H2O are mixed. The limiting reactants is, what is the limiting reactants here? Limiting reactants here is iron or H2O, neither Fe3O4. The correct answer is Y. Okay, in this experiments or this problems, how NFE, Fe 3Fe plus 4H2O, 4H2O, it is produces Fe3O4 and 4H2O. Which of them is the limiting reactant? Now we want to divide 16.8 into 56 or 55.9. This is number. To know the number of moles, we have 0.3 moles of iron. Reacts with H2O. H2O is 10 gram. We must divide it 10 gram into 18 because 18 equal to 0.56 moles. The ratio is to 1, we have 0.3 and to 0.56. This is the ratio. We have the smallest thing is iron. Now 0.3, that's 0.56. So the limiting reactant is iron. So the answer is A. The answer is A. Okay. Now we can detect the number of moles detected in these equations. In these equations, we can to know the actual limiting reactants. CaO plus H2O produce CaOH by 2 F 1.5 gram of CaO and 1.45 grams H2O are used in the mass of waters left and reacted. Why? So we have methods. We have methods. The correct answer is what? You must know firstly which of the limiting reactants, CaO or H2O. Okay. By using limiting reactant, you can know the remaining of the other. If CaO is the limiting reactant, now excess amounts of H2O is consumed partially, and we have remaining of H2O doesn't react. Now we must know that what number of moles of 1.5 gram. You must divide 1.5 gram into molar mass of CaO, now equal to 0.0268 moles. Okay, now repeat the same steps, and the H2O 1.45 divided to 18. Now the number of moles here is equal to what? Equal to this is needed, equal to this needed what? How many moles here? One mole only. So 0.0268 moles needed the same number, 0.0268 moles. Okay, now we have 0.48 only. What the remaining, when you have 1.45 gram of H2O, what did you need? You need 0.48 grams. Okay, you must subtract 0.48 grams from the 1.45, so the remaining is 0.97 gram. So the true answer is B. So the answer is B. Now you must know the way. You must know the way to calculate the limiting reactants. So you must know the other what? The other actants, because the other actants have unreacted unreactants. Okay. We want NH4NH3 plus 7O2, 4NO2 plus 6H2O. The least oxygen moles to oxidize 16 moles of ammonia gas. This is the question. The least oxygen moles to oxidize 16 moles of NH3. Okay, we want to know number of moles of oxygen needed to oxidize NH3. Now we have number is 7 oxygen. Okay, 7 oxygen needed. When you using this number 16 moles, 4 needed 7. 4 needed 7 moles. Okay, so 16 needed what? Now X again, 4 moles of ammonia gas needed 7 moles of oxygen. 1 mole, 16 mole of ammonia gas needed X. X is an unknown number of moles of oxygen. So multiply 16 times 7 over 4. Okay? Again, 16 over times 7 over 4. 7 over 4 times 16. So number of moles, 28 moles of oxygen. This is the answer, is B. Now, to conclude this, you must know how can you calculate that. How we can obtain this formula. I told you before, you make equation. 4NH3 needed 7O2. 4 needed 7. So 16 needed what? 16 times 7 over 4. So the answer is 28. So the correct answer here. To magnesium needed 1 mole of oxygen, 2 MgO. If 2 mole of magnesium are mixed with 2 mole of oxygen, okay, 2 mole of magnesium needed 1 mole only, not 2 moles. So you have excess amounts of moles numbers equal to 1 mole of oxygen. The produced MgO and leftover oxygen are what? 2 Mg needed 1, so we have 1 mole remaining from oxygen doesn't react. Okay, the produced MgO and leftover oxygen are what? We have 2 MgO plus 1 mole oxygen left. 2 mole MgO 0 mole of oxygen left. 1 mole of MgO, 0 mole oxygen left. 1 mole MgO, 2 mole, 1 mole. So we have 2 moles of MgO. We have 2 moles. Doesn't change because we have 2 Mg produce 2 MgO. So have 1 mole of oxygen remaining without reaction. And we have 2 mole of MgO produced in this reaction. Now, the answer A is true. We have 2 MgO produced and 1 mole of oxygen is what? Doesn't react. It doesn't react. Okay, 2Li plus F2 produce 2LiF. Fn, F2 equal to, this is what the meaning of N, I mean number of moles, equal to 0.092 moles. This is the limiting reactant. The mass of Li, F, no, I'm sorry, here, LIF produced is dependent on Li, not F2, no, because we have F2 is the limiting reactant. So LIF depending on limiting reactant, not Fe, not F2. Okay, so the answer equals to. Now, we conclude that from this equation, from these discussions here, 2 moles of lithium produce 2 moles of lithium fluoride. So the ratio is 1 to 1. Okay, so 0.092 moles of Li produce the same number of mole LiF. So molar mass of LiF equal to the molar mass you have. Now you know the LiF equal 2 times 0.092 times equal to this number of moles. You can to calculate it and convert it into grams. So have the answer is 26 gram per mole. This is a molar mass. Now the correct answer is B, 4.79. For how to know this number? Now we have number of moles produced, this number of moles produced. Now we have the mass and we want to calculate this by using the calculations of this number. This number is 26 gram Li plus F. F equal to 19, Li equal to 7, 7 plus 19 equal 26. Here, this is number. Okay, this is a molar mass. Now, you multiply the numbers here you want to the molar mass, it produces this number, 4.79 of lithium fluoride. 6 mole of lithium reacts with 1 mole of nitrogen, produce 2 mole of lithium nitride. F 0.5 moles of lithium and 0.125 moles of nitrogen reacted. I want the mass of lithium nitride. Now, the methods here, lithium is a limiting reactant. Why? Because you have 0.5 moles of lithium. Okay? And you need 6 mole lithium. 6. Not 1 mole. And nitrogen 0.125. So the limiting reactants of this reaction is lithium. So the LiCl, Li3N depends on lithium, not nitrogen. Now, limiting reactants product 0.5 times 2 over 6. 2 over 6. Why? Because lithium nitride equals 2 more in the standard equation. And you must divide it into 2 over 6. Now you predict the number of Li3n equal to 0.1667 moles of lithium nitride. You will convert it into number of moles. Now here multiply into Li3n. Molar mass of Li3 equal to 3 times 7 plus 14. So equal to 3, 21, 21 plus 14 equals 35. You must multiply this number into 35. Here, this is a molar mass of lithium nitride. So the actual correct answer is 5.83 grams. The answer is C. The answer is C. These problems depends on the experience you have in the balance equation and the calculation of chemistry in stereochemistry. CH4 plus 2O2 produce CO2 plus 2H2O. If 1 mole of CH4 is mixed with 4 mole of oxygen, 1 mole needed 2 mole only. Okay. Now you add 4 mole of oxygen. Yes. So methane CH4 will consume 2 moles only. CH4 totally consumed, it is a limiting reactant. And you have 2 moles consumed, and the remaining of oxygen is O2. Okay, now discussion is true. Total moles of products are. Okay, you can't predict that. CO2, 1 mole. Okay, 2H2, 2 moles. And we have 2 remainings of 2 moles of oxygen. Now we discuss assay equation. This is, we have 2 plus 1 plus 2. 2 plus 1, 3 plus 2 is 5. So the answer is what? 2 plus, I'm sorry. This is 1. The CH4 limiting needs 2 moles of oxygen. Okay. The products, 1 mole of carbon dioxide. Okay. 2 mole of water vapor. Okay. So the number of moles produced here. But I have another 2 moles of oxygen. It's asked me total moles of products only. Okay, 1 plus 2 equal to 3 only. And if he asks the total components of reaction, you will add 2 moles of oxygen. So the answer is D. But here the answer is B, because he asked me total moles of products are. Products means carbon dioxide and water vapor. Doesn't mean oxygen in this questions. 2CO plus oxygen produce 2CO2. If 20 milli of carbon monoxide burns in 40 milli oxygen at same temperature and pressure. Total gas here, ask here, total gas volume after reaction. This is enclosed system. Enclosed system. No gases. If totally carbon monoxide burned, so you have oxygen remained in this reaction. I want the total volumes here. Now we discuss that. I have 20 milli carbon monoxide. This is actual. And 40 milli of oxygen. This is actual. Now, the methods here. We discuss carbon monoxide when you calculate number of moles, 20 over 24 or 22.4, if you want, according to the. I will use 22.4. Okay. Now 20 milli times the 10 power negative 3, because you must calculate that by liter, because you divided this number into volume per liters. So needed 10 milli of oxygen. 20 milli needed 10 milli. 2 needed 1. 20 needed 20 needed 10. Okay, 20 needed 10 milli of oxygen. Okay, 10 milli of oxygen is needed for this carbon monoxide. We have oxygen remaining in this reaction equal to what? 30 milli, because you consumed 10 milli only. 10 milli only from 40. Okay, carbon monoxide totally consumed. Oxygen, we have 30 milli remains, and 2 carbon dioxide. Carbon dioxide is 20 milli. Okay, so total is 30 remains from oxygen, and 20 milli carbon dioxide is produced, so the total is 50 milli. 50 milli. This is the correct answer now in this reaction. Now we transfer for the empirical formula, and you are calculating empirical formula from the percentage of or the mass the mass of any substance or the combustion process. Empirical formula of compounds with 17.5 percentage Na, 39.7 percentage Cr, 42.8 percentage oxygen. Now we have different or fixed way to know that. Now we have this way. You must divide it 17.5 Na23, 39.7 into the mass equal to molar mass of chromium equal to exactly 80, 42.8 divided to 60. Now you must the fraction number here in this equations, and when you're using these equations, now we must know the way. This is way is Na2Cr2O7. Now how can you that? I knew that by using the fraction number. I told before I divided this number into 23, this number into 80, this number and 60. Now you have fractional number. You divided the all fractional from the reduced from the division to the least number of moles you have. Now you have integer number 1 1 1 1 3.5. Okay, 3.5. Okay, and you multiply all these atoms into 2. This is the actual number here is Na2Cr2O7. Na2Cr2O7. Hydrocarbon burns to give 3 moles of carbon dioxide and 4 moles of H2O per 1 moles hydrocarbons. Its molecular formula is. Now we must know which hydrocarbon by using 3 CO2, 4 H2O. Now the components is 3C and the 8, okay, 3C. Why? Because a hydrocarbon consists of C and H. C and H, okay? C and H. C, 3, so C3. Okay, and oxygen, let's not care here. 4 times 2, 8. So the C3H8. C3H8. Okay, this is the answer is true. This answer is 3. Okay, you can to predict number of mole of hydrocarbon, which consists of carbon and hydrogen, when it burned in air, X amount of air. So we have 3 CO2. So number of mole of carbon equal to 3, and number of hydrogen equal to 4 times 2 equal to 8 hydrogen. So the molecular formula of the compound is C4 and C3H8. C3H8. It is easy to solve this problem. Assembled yields 88 gram carbon dioxide. Now we haven't the number of moles, but we have the mass. You can to convert this mass into number of moles, and you can to predict the number of moles of carbon and hydrogen in the hydrocarbon compound. Now, we have 88 grams of carbon dioxide produced and 45 grams H2O. On combustion, a molar mass is 58 grams per mole. So the molecular formula is, now we have a way. You must calculate firstly number of mole carbon dioxide. Okay, divided 88 to molar mass of carbon dioxide. Okay, 88 divided to 44 equal to 2. Okay, we have produced 2 moles of carbon dioxide. 2 moles of carbon dioxide. Okay, and number of mole of hydrogen 45 divided to 18. This is the fraction number produced. This is I told here 2 moles. Okay, number of hydrogen equal to 5 moles. So you can write is C5. Sorry, C2. This is his C2. H5. Yes, this is true. Now this is the empirical formula. I want the molecular mass. Molar mass, I'm sorry. Molar mass is 58. Molar mass is 58. Okay. The molecular formula is what? I have C58 will divide it into 29. So the actual is C4H10. C4H10. The true answer is C4H10. Now, this is the empirical formula is C2H5. How can you use this C2H5 from this number of moles? We have C2 and H5. Calculate the molar mass of C2H5 equal to 29. 2 times 12 plus 5 equal 29. This molar mass is 58. Divided 58 into 29. We want to know the number of units of empirical formula, 2 units. Okay, multiply the number of units to the empirical formula, C4H10. See, this is converted into C2 times 2 will C4H10. This is the answer. This is the answer. So the actual is for C4H10. An alcohol 0.255 gram sample gives 0.5632 grams carbon dioxide and 0.306 gram of water vapor. The empirical formula is, what is the empirical formula here? Now the empirical formula, now, can you know that before by using alcohol unknown structural. Okay, we focus here in this number of carbon dioxide, mass of carbon dioxide, okay, divided into 44 to know the number of mole of carbon dioxide, and you predict the number of carbon, and the same in water vapor. Now you can to know the number of carbon and hydrogen, and you will predict the number of oxygen. Now we have carbon equal to 0.563 times 12 over 44. We have this number of gram. Now hydrogen is the same. This number 0.3306 times 2 over 18 equal to 0.034 grams. And oxygen equal to this number. Why? Because you have mass of oxygen, carbon and hydrogen, and total mass of alcohol. You subtract this number from total summation, of mass carbon and hydrogen in the sample. Now we have 0.0674 grams of oxygen. Now you have oxygen and carbon and hydrogen in the components of the compound. So the carbon and hydrogen, now this is ratio is 381. 381. So the carbon is 3, carbon is 3, 381. Okay, this is answer is C3H8O. C3H8O. This is the answer is here for this the compounds you want. C3H8O. C3HO, C3H8O, you can't write it C3H7OH. C3H7OH. Okay. Now, this number CH2 is empirical formula. FEF means empirical formula is CH2O, and 0.05, 0.0833 moles contains 1 gram hydrogen. The molecular formula is, okay, you want to predict the molecular formula by using the empirical formula. If you know we have 1 gram of hydrogen, you must predict the other. Now we have hydrogen in the empirical formula. How many hydrogen here is 2? How the mass of hydrogen is 1. So the units equal to scalings to 1 gram hydrogen oxygen, and the oxygen equal to this number. You can to predict the total mass. Now we have the empirical formula is CH2O. Okay, you must using this ratio, and ratio equal to 6 units. Okay, multiply 6 units into CH2O, so the answer is C6H12O6. C6H12O6, it is the true answer. The molarity of a solution made by dissolving 2 gram NaOH in 500 millis. Now we discuss the concentration. Now we did transfer in this things in the concentration. Concentrations here, review another number of moles divided into volume of liters. Okay. The molarity equal to this, we want to do calculate it. If you have 2 gram of NaOH. Okay, 1 mole of NaOH equal to 23 plus 16 plus 1 equal to 40. So the mass equal to molar mass equal to 40. Now you can divide it 2 into 40 equal to the number of moles of sodium hydroxide equal to 0.05 moles, and the volume equal to 0.05. If you have, I have 500 milli. Okay, 500 milli it converts to 500 milli. It is converts to 0.5 liter. Now you can divide 0.05 to 0.5. Now we have 0.1 molar in this aqueous solution, so the answer is 0.01. Answer is B. The mass of NaNO3 in 400 milli of 0.5 molar solution is. Now you must know the methods. 0.5 molar, this is a concentration, multiply to 400 over 1000. Why? We need this volume by liter. Okay, 0.5 times 0.4 equal to 0.2 moles. Now we have number of moles of sodium nitrate. Now we want the mass. Okay, now we must know the molar mass of sodium nitrate. 23 plus 14 plus 3 times 16. Now we have 85. This is mass molar mass of sodium nitrate. And we have number of moles 0.2. Okay, multiply number of moles times the molar mass equal to mass equal to 70. So okay, this is answer is B. Is this the true answer? And you must firstly know the way to calculate, way to solve these problems, not the answer only. You must using the pencils and papers to and calculator to write these equations and write the same the molecular formula and calculate the molar mass and the converting volume from liters to milli and vice versa. This is help you to solve any problem for this, and you must save the last law to solve these things. I reviewed with you the molar mass and how to calculate number of mole from the mass and molar mass and volume per liter and volume of gases. These very important for you to solve any problems, and it is necessary for you, right? And you have given and request any problems. It consists of given and request. You must starting the solving by the end of the problems, the end of the problems. And the end of the problems, it is easy, it's easy to solve this. In this questions on this problem, in 0.4 molar AlCl3, the concentration of chloride ion is, okay, we must using AlCl3 dissociation process. We have Al plus 3 plus 3Cl negative 1. Okay, now we must have Al plus 3 plus 3Cl negative 1. Each 1 mole of AlCl3 produces 3 moles of Cl negative 1. Now AlCl3 equal to 3 times 0.4 molar. This is the concentration of AlCl3 is the same of AlCl3 of the same of the ions here. Now 1.2 molars from this concentration, we can to calculate it as easily for these equations. Now we have what we have 0.1 time 3 times 0.4 equal to 1.2 molar. So the actual is C. Now it is correct answer you need, but you have depending on the ways to solve this equation. Mixing 30 liters of 1 molar HCl with 200 liters of 3 molar HCl gives final molarity as. Oh, this is very, very, very enjoyed. You must enjoy here these reactions, and this you have a new idea. You must enjoy really for this concentration. You have two concentration added to other 30 liters of 1 molar HCl with 2 liters of 3 molar HCl gives a final molarity of. Now we want the final molarities here. If you added number of moles and number of moles again, okay, 1 molar times 30 liter, the number of moles here is 30 moles. Okay, 3 molars times 20 equals 60 mole. Add 60 mole to the 30 moles equal to 90 mole, and you have total volume equal to 50. Now we have 50 liters and we have 60 mole. Okay, another way you can to divide it 60 90 moles to 50. Now you know the final concentration is what 1.8 molar. Okay, understand me? Now you have first way calculated the number of moles of HCl, first way, or the first step here, and number of moles here of HCl, another, and added the number of moles here and number of moles here, you have 90 moles. And we have two volumes added, 30 plus 20, so you have 50 liters. Okay, final molarity equal to final number of moles divided to final volume. This is a method here equal to 1.8. Diluting 50 milli of 0.2 molar HCl by adding 200 milli water. I want to know the final molarity. Now, I told before M1 times V1 equal to M2 times V2. Did you remind me? Now, 50 milli of 0.2 molar, this M1 times V1. Adding 200 milli, so that new volume equals to 250 milli. Okay, 50 times 0.2 equal to 200 times unknown molarity. Now it's easy to know the unknown molarity. This is a values here equal to what? 0.04 molar. So the answer is D. The answer is D. I told before, you must save the law to help you the solving of any problems. How much waters must be added to 10 milli of 6 molar HCl to obtain 0.5 molar? Now, we have the same law. M1 times V1 equal M2 times V2. What is the given you have? I have in this problem 10 milli 6 molar HCl. Okay, 10 times 6 equal to 0.5 times V2. So V2 equals to 60 over 0.5. Okay, 60 over 0.5. Now we know the new volume. New volume is 120. You have before 10 milli, and new volume is 120 milli. So you add 110 milli of a water to reach in this concentration 0.5, and before molarity is 6 molar. This is the dilution process you make. What mass of NH3 has the same volume as 8 gram oxygen at RTB? Okay, it's easy. Firstly, you must convert 8 gram to number of moles. Okay, and you must convert. Know that I have no given. Okay, 8 divided to 32. 1 over 4, 0.25. Now we have 0.5 moles of oxygen. Okay. So the number of moles of ammonia gas equal to 0.5 mole. No, I want the volume at RTB. Okay, you have 0.25 times 24. Now you know the volume. If you wanted to know the mass, okay, times 70 time into 70. If you want volume, so times 0.25 into 24. If you want the mass, this smaller mass equals 70 here. 0.25 times 17 equal 4.25 grams. This is answer is B. Now, this is easy to understand that before N 2NH3 plus 3CuO produce 3Cu plus 3H2O plus N2. What volume of NH3? Volume NH3 in the product? No, I'm sorry, this is reactants. Okay. At STB reacts with 6 gram CuO. This problems depends on two sides. First sides review the balance and chemical calculation. Second side, the volume. Third side, limiting reactant. Now we want to know 2NH3. 2NH3 needed 3CuO. I have 6 gram. Okay, use here by grams. And I need that by volume at what? At RTB. Okay, 2 times 24 needed 3 times what? Bracket 63.5 plus 16. So we have this way to calculate the predicted gas of NH3. Okay, you have molar mass of Cu equal to 79.5. Okay, so the number equal to 6 over 79. Okay, this is number. Ammonia gas, we have in the standard equation is 2 moles of ammonia gas. Yes. Now you apply the crossway. The volume equal to 0.13 liters. Now this is the true answer here in this equation. 264 gram strontium reacts with 213 grams chlorine. The compounds formed is. Now we have mass. We want to know the number of moles of strontium. And we want the number of moles of chlorine. I don't know anything about strontium. Strontium SrCl2. Okay, but if you save the components, that's. But here we want to know the valences, SCr. Now we must know the number of moles. Divided 264 into molar mass of strontium equal to 87. Now we have 3 moles, approximately 3 moles of SR. And chlorine Cl will divide 213 to what? To 35.4 for 1 Cl. Now we have 6 moles. Okay, we want to know the ratio between SR and Cl. We have 3 to 6, 1 over 2, 1 over 2, or 2 over 1. So chlorine is 2 and the strontium is 1. So the components equal to SrCl2 by using number of moles of each atoms in the compounds you predict in this equation, or they will predict in this problem. Mixing 75 milli of 0.05 molar HCl with 25 milli of 3 molar HCl, the final molarity, please. Okay, the same way you have the number of moles of each component. You have 70 milli of 0.05 molar HCl. You can to multiply 75 times 10 power negative 3 times 0.05. Now you can to obtain the number of moles HCl. Okay, with 25 milli of 3 molar times 3 times 25 over 1000, you can to calculate the number of mole of HCl. We have 2 HCl added to each other. Now we have number of moles here plus number of moles here, and you must divide it to 100. Why? Because you have mixtures formed from 25 milli and 75 milli. So we have 100 milli. So the final molarity is what? Review these numbers. Now you follow me when I calculated this by your calculator. Now I told these steps. Now the molarity, final molarity is what? Is 0.7875. D is the correct answer. Now we have mixing 75 milliliters of 0.05 molar HCl with 25. This is answers here. I ensure this equation for to completely solve this accurately. What volume of 0.5 molar BaCl2, the solution, contains 3 moles of chloride ions. Okay, when BaCl2 contains Ba plus 2 plus 2Cl negative 1. 0.5 molar of BaCl2, 3 moles Cl. We know the volume of this solution. 1.5 Cl needed. So the volume is 3 liters. The volume is 3 liters. Again, BaCl2 connected with each other. Ba plus 2 plus 2Cl negative 1. تمام. Each unit here, BaCl2 needed or dissociated 2 moles of ion Cl negative 1. Okay, so 0.5 reduce what? Reduce the 1 mole equal to 0.5 equal to 1. Now we have 1.5 moles of BaCl2. Why? Because you have 3 moles of Cl negative. According to the ratio between Ba and 2Cl, 1 to 2. Okay, 1 to 2. If you have 3 here, so barium is equal to 1.5. Now you can to know the concentration. Concentration I have. Now we want the volume. Okay, what the volume of what? Of BaCl2. So we have 3 moles of Cl negative. So I have 1.5 moles of BaCl2. So the volume equal to number of moles divided into molarity equal to 3 liter. Equal to 3 liter. What the compounds has molecular formula equal to empirical formula. Molecular formula equals empirical formula in this way. Mf equal to Ef. Here this answer. We find here why you can obtain that. This is simplest integer ratio, and also here in this compound I have many examples. C4H6, N2H4, K2O2, V2O5. Each of this one you can do if you divided this into number 2, so empirical formula is C2H4 or C2H3, I'm sorry. Here C2H4, N2H4, empirical formula equal to NH2. K2O2, empirical formula is KO. V2O5, I can't do division anything, so we have 2, 5. This is the simplest form. So the empirical formula is the molecular formula the same. It is easy to know that. Okay, the nitrogen oxide with 63.64% nitrogen biomass has empirical formula. What is the empirical formula of NO, N2O, NO2, NO only? How can I know that from this 64.64 percentage of nitrogen. Okay, what is the oxygen? I told before. I told before. This is a compound or empirical formula 100 percentage. Okay, subtract 100 percentage from 63.64 percentage. You have the answer is 73. 73 maybe or 63. I call here 63. Yes, this is true. This is, I know that from this equation. 36 36.36. Okay, now you can to divide 63.64 into 14 because it's, you know, the number of mole of nitrogen, and we have 36.36 of oxygen divided in 60. Now you have number of mole of nitrogen is 2.27, and the ratio of nitrogen and have, I'm sorry, nitrogen 4.5, and the oxygen moles equal 2.2. So the ratio equal to 2 into 1, 2 into 1. So N2, N2O, N2 as its empirical formula. N2O is the empirical formula. This is B. This is SB. Now we review all examples. Number of moles, mass, molar mass, volume of gases, empirical formula, molecular formula, concentration, and the dilution. I collect all things in this sections of part 2, chemical calculations. Now we finished our sessions, and next we will start in the chapter 2 and 3 the same. We have 4 sessions for this revision, and we apply some problems for this. And thank you for good listening. I will hope today good for you. I will meet you another session inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.